So this one equal to divergence f. Divergence f means 4z plus xz square plus 3, okay, into, I'll take in this order, dy, dx, dz. Since z is having numerical variables, so I have taken z as last preference, outer integral. Similarly, x also having minus 4 to 4 numerical limits, I have taken the second order. Next, this is having variable quotients, variable limits. So whenever you are having variable limits, take it as first preference. So here I have to take minus root 16 minus x square to plus root 16 minus x square. Okay. Next minus 4 to 4. Next 0 to 4. So these are the limits for z, x and y. So this one equal to integral 0 to 4, integral minus 4 to 4. Okay. Now we have to integrate this one with respect to z now. So in this quotient, z variable is not there. So that means integral 1 dy you will get. So integral 1 dy is y. So I'll get 4z plus xz square plus 3 into y, having the limits from minus root 16 minus x square to plus root 16 minus x square. Okay, so dx dz. So now apply the limits. So this one equal to integral 0 to 4, integral minus 4 to 4, 4z plus xz square plus 3. Okay, so here if you apply upper limit, what happens? Root 16 minus y square will get, 16 minus x square minus of minus root 16 minus x square. Okay, so dx dz, so equal to 16 0 to 4, integral minus 4 to 4. Okay, 4z plus xz square plus 3. So here how much will get? 2 root 16 minus x square will get dx dy. Dx dz. So now multiply it into each integral. Okay, if you multiply it into each integral, how much you get? Integral 0 to 4, integral minus 4 to 4. First term is 2 into 4, that means 8z root 16 minus x square dx dz. Okay, plus integral 0 to 4, integral minus 4 to 4, 2 xz square. Okay, or you can write it as 2 z square x root 16 minus x square dx dz. Next plus integral 0 to 4, integral minus 4 to 4. Okay, next 3 into 2, that means 6 root 16 minus x square dx dz. Okay, so now this one equal to integral 0 to 4, okay, integral minus 4 to 4. So here 8z. So if you want to apply the integral, just will write the integral value 8z, I'll write. So you need to integrate this one, right? So integration of root a square minus x square dx. How to write this integral value? So this integral value is x by 2 root a square minus x square plus a square by 2. Okay, this is sine inverse x by a. So this is the formula for integral root a square minus x square dx. Okay, so we are going to apply the same formula here. So what happens? X root 16 minus x square divided by 2 plus a square by 2, that means 16 by 2. Okay, sine inverse x by a. So x by a value is 4. Okay, so limits are from minus 4 to 4 plus. Okay, so x into this one is there. Okay, so it will be little bit difficult to evaluate this integral. So for that sake, what I will do is I will make use of integral properties. Okay, so according to the definite integrals, integral minus a to a f of x dx is equal to 0 if f of x is odd function. Okay, similarly 2 into integral 0 to a f of x dx if f of x is even function. So what do you mean by odd function or even function? How to define what is odd function? It is defined as f of minus x is equal to minus f of x. Clear? So whenever you replace x with minus x, so you will get minus of the same function. So if it satisfies this condition, then that is called odd function. Okay, even function. So the definition of this is nothing but f of minus x must be equal to f of x plus f of x. So even if you substitute x with minus x, the value should not change. Okay, so such kind of equations are called even functions. Okay, fine. Now we have to check whether this x into root 16 minus x square is even function or odd function. If it is that, the integration will be very easy. Okay, so implies f of minus x, replace x with minus x in this. How much you'll get? Minus x
into root
root
of
16 minus x
x square.
square. Yes. So this is nothing but minus f of x. Correct or not? X into root
Yes,
16
sir.
minus x square is f of x itself. So you got minus f of x. Directly you can put this output as 0. Since it is varying from minus a to a. So that means minus 4 to 4. So second, this one is 0. Okay. Now plus, come to third term, integral 0 to 4. Okay, 6, this 6 I am keeping outside. Okay, so check whether this one is even function or odd function. F of x is equal to root 16 minus x square is there, implies f of minus x will be how much? Root 16 minus x square is x square itself. Clear? So this is f of x. So f of minus x is plus f of x. Okay, so you'll get 2 into integral of 0 to a. Okay, so write that. So here 2 into root 0 to 4. Okay, so here you'll get 1 minute 6 integral 0 to 4. Here this one you are doing it as 2 into integral 0 to 4 root 16 minus x square dx. Okay, so this is limit. This limit is for z. So dx dz will get. Okay, so these are the things you need to remember. So I'll continue in the next slide. So this one equal to, if you apply the limits for first term, what happens? We'll see. Integral 0 to 4. Okay,
2
dz
root
will be
0.
there. Huh?
2 root 0.
Yes, 2 root 0. Okay,
Plus
by
8
2
sin inverse 1.
plus 8 sine
Sin
inverse
inverse
1
1.
minus again 2 root 0 by 2 again plus 8 sine
8
inverse
minus 1.
minus 1. Okay, so dz will be there. Next plus integral 0 to 4. Okay, here 12 will be there outside because 6 into 2. So 12. So apply the same formula here also. What happens? X by 2. Sorry, here this is 4 now. Here minus 4. So x by 2 root 16 minus x square. Okay, plus 16 by 2 root sorry, sine inverse x by a. Sorry, 4 minus x by 4, having the limits from 0 to 4 dz. So this one equal to integral 0 to 4 8z. So these two terms get cancelled. Okay, so here sine inverse of negative, that means minus sine in.
Minus 5 by 2.
So minus of minus, so I'll get plus pi by 2 into total how much?
4 pi. 8 pi. 4 pi plus 4 pi. 8 pi.
Here into 8 pi you'll get. So 8 pi dz plus 12 into integral 0 to 4. Apply the limits. How much you'll get? 4 by 2 root
Same,
0 plus 8. So 8 into pi by 2 minus 0. So 0 into this one is 0 will get dz. So this one equal to 8 into 8 64 integral 0 to 4 sorry 64 pi. So 64 pi dz plus 12 into how much?
Sir, Z dz, sir.
Huh? Z is there.
dz, sir. Yes, sir.
Z. Z dz. In the last term you don't get. So here 2 ones, 2 fours, 4 12s. You'll get 48 here. 48 pi integral dz. Limits are from 0 to 4. So 64 pi into z square by 2, having the limits from 0 to 4, plus 48 pi z having the limits from 0 to 4, 68 pi into
Sir,
16 by
one
2.
mistake. Sir, one mistake is there, sir.
64. Yes.
Sir, in the first, sir, here, in this slide, first one, sir, you have
Uh,
applied in second line, sir.
uh,
You have applied limit as 0 to 4. It should be minus 4 to 4, no?
that is what. Here what happens? 2 into, sorry, here, this I have applied. 2
Okay.
into integral 0 to 4 f of x dx. That's why you got 12 here now.
Ah,
Okay. So for that sake, you get 12 here. So plus 48 pi into 4. Okay. So 8. So 16 into 64 into 8. 512, I think. 512 pi plus 192 pi. So total how much? 2, sorry, 704. So 704 pi will get. Fine. Yes, any doubts? Let's go through it once. Fine. We'll go for this. Next year, evaluate double integral yzi plus zxj plus xyk dot n cap ds, where S is the surface of the sphere. Okay. X square plus y square plus z square equal to a square in the first quadrant. And that means in the first octant here is given. What do you mean by first octant? Usually in
three-dimensional space, first
yes,
part. In three-dimensional space where x, y, z are positive.
yeah. Actually, when you are plotting two-dimensional space, you'll get 4 quadrants. Okay, but when you're drawing three-dimensional space, you'll get total 8 quadrants. So, and that in that he is selecting only one quadrant. Okay. So quadra means 4, octa means 8, right? So in 8 ways you can write it. So that's why this is called first octant. So in three-dimensional space, in the first octant, you have to find the area. Okay. So let us see how to solve this. Okay. So here we have to use only surface integral. So let us see how to solve in surface integral. Uh, Here the given surface is this much. So here the problem is finding n cap only. This is the main problem. Okay. So if you find n cap, then it's not it. Yeah, directly you can do this. Okay. In the first quadrant means, in the first octant means which plane will be there? In the first octant means we can take directly xy plane. Okay. So the surface x square plus y square z square is equal to a square they have given. So if you want to find the normal for the surface, what we'll do? Vector normal will find. Vector normal. How to find vector normal for this? First part of the chapter. That is gradient of the surface. Okay. So that means del phi. If you take this as phi. Okay. So find vector normal for this. Del phi is equal to dou by dou x of x square plus y square plus z square minus a square plus I plus dou by dou y of x square plus y square plus z square minus a square into j plus dou by dou z of x square plus y square plus z square minus a square into k. Okay, so this one equal to how much will get? Check once. 2x plus 2y plus 2z, 2xi plus 2yj plus 2zk. Okay, so this is vector normal. Okay, but you need n cap. What is n cap? Unit vector normal it is. Okay, so n cap is nothing but del phi divided by modulus of del phi is equal to how much will get? Del phi 2xi plus 2yj plus 2zk divided by root of, so 2x square, that means 4x square plus 4y square plus 4z square. So this can be rewritten as 2 into xi plus yj plus zk divided by, if you take 4 common, you'll get 2 root x square plus y square plus z square. Okay, so these two to get cancelled. So n cap is equal to how much? Xi
plus
yj zk
plus zk divided by root of x square plus y square plus z.
Root of, what is this actually? X square plus y square plus z square is a square.
Yes.
So square root get cancelled. Xi plus yj plus zk divided by
Okay.
a. Okay. Now what we are doing, surface integral means only 2 dimensions should be there. Okay. So you have to remove either z value or y value or x value. Okay. Since he has told that it is in first quadrant or first octant, we have to project that in xy plane. Okay. So projecting the given surface, on xy plane implies z value will be 0. Okay, So implies what will be your f function? F function equal to x, sorry, yzi plus zxj plus xyk, okay, implies f is equal to how much you'll get if you substitute z equal to 0?
XYK.
Hmm?
XYK.
xyk, okay, implies f dot nk, or first you can find f dot n and then substitute z equal to 0, that will be better. Okay, so implies f dot n cap is equal to yz into x by a plus zx into y divided by b, sorry, divided by a. Next, xyz divided by a. Okay, so this one implies f dot n cap is equal to this much we got. At z equal to 0 you substitute. Okay, how much you got this?
0. 0.
So 1 minute. So I need it. Okay, we'll get how much? First, I'll write as it is 3xyz. Okay, divided by a will get. Okay, but we need to find n cap, right? Uh, n cap into ds is equal to. So if that n cap we want. There's something they have written. Okay. Projection of xy plane on xy plane. Projection of the surface in xy plane is equal to this value is n cap dot k. Okay, so that means Here dx dy must be equal to n cap dot ds. N cap dot k ds. Okay. So what is n cap dot k ds? We have to find. Okay. ds is equal to how much we'll get? N cap. N cap is this dot k. So that means we'll get z by a. Okay. So this must be equal to dx dy. Okay. So what will be this value then? N cap dot k ds is equal to, send this one to this side, dx dy divided by a by z or into a by z. Okay. Now I will substitute in the place of n cap ds as this much. So implies surface integral s f dot n cap ds is equal to, so f dot n we got it as this much, 3xyz into dx dy divided by z into a. So this z get cancelled. Integral limits we need to find. So how does the integral value in limits change?
Sir, 3xyz by a, sir.
That will be there. No, here into a will be a by z, no? So
No,
z
f
by
dot
a.
n cap is 3xyz by a, sir.
Huh?
F dot n
3xyz
cap.
by a. Yes. So by a. So this a also got cancelled. Okay. So this one equal to 3 into double integral xy dx dy. Okay. Now the sphere got circle, right? If you take z equal to 0 here. Okay. This one. Taking z equal to 0 will get circle, equation of circle. So for that you are considering only this part, first octant. So the limit will be 0 to root y minus a square. Okay. So x limits, here dy dx I am taking. Okay. X limits are from 0 to a. So this is x square minus a square. This is a square minus x square. Since we got x square plus y square equal to a square, implies y value I am finding, y square equal to a square minus x square, y is equal to root of a square minus x square, but we are considering only in first octant, so it will become only positive value. So 0 to this we are finding. Next, if you put again it's 0, what happens? A square minus x square equal to this much, x square equal to a square, x equal to plus or minus a, but we are taking only positive one because it is in first octant. So the limit will be in this way, is equal to 3 integral 0 to a. Okay. So integral 0 to root a square minus x square xy dy dx. Apply limits for y. Okay. So what happens? x into y square by 2, 0 to root a square minus x square dx. We'll get 3 integral 0 to a x into a square minus x square by 2, okay, minus 0 I'll get dx. So 3 into how much? So 3 by 2 I'm taking outside, ax square, sorry, a square x minus x cube by 3, sorry, x cube. Okay. Three by two, a square x square by 2 minus x power 4 by 4. Okay, limits from 0 to a. 3 by 2, okay, a power 4 by 2 will get minus a power 4 by 2. Sorry. Here by 4 is there. So
3a
equal
to
to
the
how
power 4
much?
by 8.
Yes, 3 by 2,
A to the
2a
power 4 by
power
4.
4 minus a power 4 divided by 8, sorry, 4. So overall answer is 3a power 4 by 8. So here this will continue. This is the continuation part of this. So this is the value of ds. Fine.
Yes, sir.
So here nothing we did. While we are projecting on given surface on xy plane, so what is the perpendicular axis to this is z plane. On z axis k vector will be there. Okay. If we want to get ds value, we need to make a dot product with n cap, normal to the surface. Okay. So you will get this much. dx dy value must be n cap dot k ds. So then you are finding ds value and you are substituting here. That's it. Next, again they have given evaluate double integral f dot n cap ds or find the flux across the surface given that f is equal to xi plus yj plus zk over the sphere x square plus y square plus z square equal to a square. I think in the previous problem also the same thing they have given. Over a sphere they have given complete sphere. Previously it was only for first octant. So that's why we have faced difficulty. Okay, if they have given for overall sphere, okay, so you can do it directly by triple integral. Okay, so first to find divergence of this, divergence of f. So I'll get I plus j plus k. Okay, so
Your time up, sir.